All right, and here we are with chapter 5. All right, we're going to go with the proof of the Pythagorean theorem. What the heck? All right, really, what I'm looking at is to answer this essential question. Now, the Pythagorean theorem is something that you guys have seen before, but I really want to answer and address why is it a squared plus b squared equal to c squared? Now, there's lots of different ways to do this. You can search up a ton of different ones on YouTube, but for right now, let's take a look at the tilted square example. All right. So, on your notes, if you are in my classes and have my notes, then you are going to be looking at this drawing already on your paper. Yeah, that's that giant square thing right there with the A, the B, and the C, and all that good stuff. So, what we're going to really look at is area. Now, area is another review topic, but really, to find the area of a square, you multiply one of its sides by the other side. Now, here's the big deal. For this square, you guys can see each side is made of two parts. So each side is A plus B, as you see here on the bottom. And then on the right-hand side, you see that it is A plus B. So to find the area of the large square, so I'm just going to use the outside sides, the outside edges. I'm going to do, since I know that one side is A plus B, I'm actually going to multiply those sides together. So A plus B times A plus B is equal to the area of the large square. Awesome. Okay, so now here's the other part. What we can also do is find the area of all of the small pieces. Now, if I found the area of all four of these small triangles and the area of the inner tilted square, I would also find the area for the entire figure, this entire shape. All right, so step by step. So to find the area of the triangles, the formula for the area of a triangle, I'd multiply A times B divided by 2. All right, but there are 4 triangles. So I know I have this formula 4 times, and that's where this 4 comes from. Now the 1/2 A times B, of course, that again is the formula for the area of one of these small triangles. All right. So let's distribute the 4. So 4 times 1/2, or half of 4. And I know that people are screaming at their televisions or computer screens right now because you know that half of 4 is 2. Okay, so the area of 4 triangles is 2AB. So 2 times the product of A times B. All right, so that's the area of just the 4 triangles on the outside of that square. Now we got to look at the area for the tilted square inside of the shape. And the tilted square is the same thing. I have to multiply one side by the other. And one side is C, and the other side is also C. So the area of the tilted square is C times C, or C squared. Awesome. So now all I need to do is combine the area of the 4 triangles and the area of the inner tilted square, which is 2AB plus C squared. Now the 2AB came from the area of the 4 triangles, and the C squared came from the area of the inner tilted square. So that gives us another way of expressing the area of the shape. So we have 2 different ways. We have the area as the outside side times the other outside side, or the bottom and the right side. So that's A plus B times A plus B. And then we have another way to express the area, which is 2AB plus C squared. Okay, cool. So as we move to the next slide, we have 2 different ways to find the area, but both of those ways must be equal. So we know A plus B times A plus B must be equal to 2AB plus C squared. Woo! Oh, now we're getting somewhere. So it's going to look interesting and get more complicated before it gets easy. Don't get scared. All right. So if I FOIL A plus B times A plus B, A times A is A squared. A times B is AB, and then A times B is AB. So I have 2 of those, and then B times B is B squared. Okay, cool. A squared plus 2AB plus B squared. That's just this left-hand side kind of just multiplied out. And I'm going to bring down the right-hand side of the equation. Okay, again, these are just showing ways of expressing the area of the square, which have to be equal. Now, the sharp-eyed among you might see that I have a 2ab on each side. Now, what I do to one side, I can always do to the other. So I'm going to subtract 2ab from each side. Let's make this thing look simpler. And what? I actually have a squared plus b squared is equal to c squared. So the simple part is that we have another way to look at the Pythagorean theorem. Yes, it talks about the relationship between its sides, but we can use any square because a and b and c are all just variables. So as long as it is as a, b, and c, the numbers, form a right triangle of some kind, this formula will always hold true because I can make this square. So really, the Pythagorean theorem is another way of expressing the area of a square within a square. Kaboom, that's the Pythagorean theorem. So our essential question, as I move back to the beginning, was why is a squared plus b squared equal to c squared? Well, a squared plus b squared is equal to c squared because really they are just two different ways of expressing the area of the exact same square. Booyah. All right, cool. So the rest of this I'm going to flip through real quickly. That was just something that we're going to be doing in class. Thank you to the person on Pinterest that put that together. And if you're with me in my classes, you're going to be writing your summary, and there is some small practice at the end of your notes. And I know that this one was really a very involved presentation. So really what you want to do is I know that you want to look over this again. So you want to make sure you understand how the Pythagorean theorem is actually just an expression of two equal areas. Sweet. All right, guys. I will catch you next time as we explore the distance formula for Chapter 5. But until then, keep doing the math.